Hi, this is Tim. Today we're going to talk about how to use your basic multimeter. This multimeter is about $25 and I'll put a link to it in the description, but it is a must-have tool when troubleshooting machines. But I find that a lot of people are a little confused on how to actually use it or what all the positions are because yeah, it has, well, you can hear them click through there. It has tons of little clicking things that you can roll through. But usually people only know how to use a couple of them. So we're going to take some time today to go through how to do your basic AC voltage measurements, DC voltage measurements, DC amps, ohms, and we'll also hit on some diodes and also the HFE. Please take a moment to like and subscribe to our channel. We put out at least one automation video a week. And ask any questions that come up in the comments. Your question this week can easily be next week's automation topic. First, when you look at your meter, you'll see that it has a V on both sides, but it has a different symbol beside of them. We have V with a little squiggly line, and here we have V with a solid line and a dashed line underneath it. Well, that squiggly line is a sine wave. And so what that is symbolizing is an AC sine wave. So V with this is going to be AC voltage, and V with this is going to be DC voltage. Also, while we're looking at these symbols, this one right here will be the other one. This is an ohm signal, and it will measure resistance. So on the front of our trainer, we actually have an AC power source. This plugs into regular wall power. In fact, let's just start with our wall outlet. Here is a cord coming off of our wall outlet, and it has two straight blades and a round blade. The round one is going to be a ground, and the shorter of the two straight blades is going to be your L1 or 120 volt typically, and your wider blade is going to be your neutral wire. So if we switch our meter to AC, and right now we'll just stick it on the 600. Michael? I do need some help. Will you hold that for me? All right, got my trusty helper Michael again. If we stick one in the short blade and the other in the long blade, then we're going to show right at 120 volt, about 122 volt. Now also on our meter, we have 600 and we also have 200. Now that is the range of the voltmeter. In other words, in the 600 one, it'll go from 0 to 600 volt, and in the 200 one, it goes 0 to 200. Well, why not always just have it in the 600? Because the range also affects the precision of it. So if we switch it to 200, now instead of showing 122 volt, we're going to show 122.8 volt. Also, a few other things while we're here on our outlet is you should be able to take the wide blade out of it and connect it to the ground and also see 120 volt. If you don't, then chances are your outlet's not wired right. So now I'm going to go ahead and connect it to our trainer. I appreciate the help, Michael. And with our trainer, we can generate a variety of voltages. And so to start with, right on the front of our trainer, we actually do have these three terminals here. This is coming right off of the wall power, 120 volt. So we have L1, which is our black wire, neutral, which is our white wire, and then we have our ground. So the same as we just checked on our outlet, if we connect between the black wire and the white wire, we're going to have 120 volt AC. Also, if we connect between the black wire and the green wire, we're going to have 120 volt AC. Off of this, we are powering our PowerFlex drive, and we're also going to our 24 volt power supply. So the drive itself generates several DC voltages, but let's start on the back side of our trainer where our 24 volt is. So on the back side of our trainer where you do the bulk of your wiring, we have these two sets of terminal blocks, and the left one is our 24 volt DC, and the right one is our 0 volt DC. So since we're looking at DC, we're going to be looking for this symbol that is a long solid line with dashed lines underneath it, and V for voltage. So that is going to be right here. And then again, we have these scalings. So let's just start at that 600 volt. And typically if I'm probing an unknown voltage, I probably would start at the 600 and then work my way down. So let's put the red on the plus 24 volt and the black on the 0 volt. All right, and we're showing 23 volts. And so let's bring it down. Now that we know that, we can bring it down to 200. And now you can see it's actually 23.9, actually bouncing on 24. Now what happens if you go too low? Because also on this meter, we have a 20 volt scale. So let's switch it to the 20 volt scale and put them back on. And it's gonna say 1 with a dot. And all of them will be a little different. Maybe they'll say OL. They have different ways of saying it, but this means that the meter is overloaded. So we'll switch back up to our 200 volt scale. Also, if you put your leads on backwards, so I put the black one on the plus 24 and the red one on the 0 volt, it's gonna show a negative 23 volt. So if you see this, chances are your polarity is wrong. Now this is only an issue on DC. AC voltage, you can put the line and the neutral on whichever lead you want. It's going to read the same. So that covers our voltage, but while we're back here, we have this 10K potentiometer. Let's talk about it. So a potentiometer is a variable resistor, and it uses the symbol of ohm. And right here we can see we have an ohm symbol. So let's start at the 200 mega ohm range. Now, if you have it on, say, 2M or 200 mega ohm, your result is up here is going to be in mega ohms. So we have a 10K pot, so we should show a very, very small number here. We'll connect across it. Okay, we're actually showing 0.004. Oh, that's right, my mistake. This one has been modified. This one has a 5K potentiometer on it. But if we check across these, and we're showing right at 0.004 mega ohm. So that's a very, very small amount of mega ohm. Now, one thing about ohms, the bigger they get, the more resistance you have to current flow. So in the case, if this was showing mega ohms, it would not flow current well at all. And we're gonna do some math equations in an upcoming video to kind of talk about how to figure that out. But now, let's switch to the next scale, which is 200K. So when we switch to the 200K scale, instead of it showing mega ohms up here, it's gonna show kilo ohms. So when we touch it this time, now instead of saying 0.005 mega ohms, we're showing 5 kilo ohms, which is the exact same thing. And you see we have 1 decimal point of precision behind it. So now let's switch to the 20K range and check it again. And this time, we're getting the same result. Actually, now it's 5.08. We've gotten that hundredths place of precision. And finally, let's switch down to the 2K, which we know is way too low on the scale, just so we can see what happens. It's gonna look like an open lead. And this is something you need to be really careful about when you're checking things. If I walked up to this and I check it, the potentiometer must be bad. Well, it's not bad. In this case, my range is too low to measure my resistance. So probably when I'm walking up to things, I don't know that I always go to the 200 meg, but I probably do get around the 200K to check things initially just to see whether it has anything. And so that's just something to be very aware of. Here's also a 200 ohm. Let's say we were checking this resistor right here. If we check it, then we're gonna show 0.1 ohm, or actually it almost says 0. I think it does, yeah, it does say 0 now. But if I go down the range here to that 200 ohm mark, then I measure it again, we're gonna see that one is right at 100 ohm. It's showing 98.5. So the ranges are very important to understand on the ohm section of a multimeter, because if you have your scale too high or too low, it can give you a false sense of security. So you'll need to adjust this as you figure out what you're actually measuring. Because for example, let's go back to this 100 ohm resistor, and we started at that 2 meg part for our potentiometer. But if we do that with this, then it's gonna show 0 ohms. So we're gonna think there's 0 resistance, like this is a piece of solid wire. But it's not, it's actually 100 ohms. So you'll need to dial that in to figure out exactly what the ohms are. And some of your nicer meters will have auto ranging on the ohms. That is a good feature if you're doing a lot of it. Honestly, I don't do a lot of precision measuring of ohms. More than anything, usually I want to know, is the wire broke? Is the wire not broke? And in those cases, any range does work. If we put this on switch 1, we show an open circuit, but we switch the switch and it's showing 0 now. And if we take it to the 200 ohm mark, then we switch the switch, open, other way, 0.4 ohms. And so that's more of what I'm usually doing, but it's good to be aware of that for when you do need to actually measure some ohms. Also, while we're here, there's also a diode symbol down here on the 2K. And what the diode checker is gonna do is it's only gonna let you measure continuity one way. So if we touch this one way, it's showing about 694. But if we flip it around the other way, then it's gonna show that it's an open circuit. And that's because a diode only allows current to flow one way. And I don't know, we may do a video kind of going through more of electronics. That's out of the realm of our channel, but I do get some occasional questions about transistors, things like that. So if that's something you'd like to see, put it down in the comments and maybe we'll do a video on it. But one other useful feature, especially if you're troubleshooting and you're not really that concerned with what the value is most of them will have this little audible looking symbol. And what happens there is when you touch the leads together, it will make noise. And so if you have, if you're on your head under a machine trying to reach up and measure something, that can really be a lifesaver. So we wanted to check switch 1 again and switch it on, off. So that's a very, very useful troubleshooting feature. So rolling on around, the next thing we have is this HFE function, and that has to do with this round connector right here. And this is specifically for testing transistors, and I'm not going to get into that in this video. Again, that's more of an electronics feature, not really, say, a control and wiring feature. Then we have our amp area. And in the case of this meter, it only does DC amps. But this is the most misunderstood and the absolute way more people damage their meter is over here on this amp scale. And we haven't really talked about it yet because we haven't needed to, but typically your leads are gonna be your black lead's gonna be in the COM post, and your red lead's gonna be in the volt, ohm, and milliamp post. Usually though, there will be a third post that is a bigger amp. So this is 10 amps DC, and this is milliamps. So a milliamp is, in fact, this one, well, it's fused for 500 milliamps. Oh, there we go. Okay, so its range is 200 milliamps on this middle one, which is 0.2 amps. And if you connect any more than that to this, then you will blow the fuse. And I'll put a link in the description that talks all about how you blow your fuses in your meter, how to check that your fuse is blown in your meter, and how to replace your fuse. So let's start by measuring a milliamp signal. So let's go over to the 200M. And again, you're gonna need to check these leads, but in the case of this meter, milliamps is on the same post as volts and ohms. And this will vary depending on your particular meter. And we're gonna use our analog simulator to generate a milliamp signal. And we're gonna put the red one on the red post and the black one on the black post. Milliamp signals are used for a lot of control signals where you're measuring something. It's not on off like a switch, such as a drive speed command, a level sensor, pH probe, anything that you want to vary a signal as opposed to it being on and off. And so we're going to turn our simulator on, and we're going to go down to current source, and we can bring it on up and simulate. We'll just go right up to 20 milliamps. Now first, this meter right here, like I said, it's a $25 meter and it is outstanding for troubleshooting. But yeah, this is probably generating exactly a 20 milliamp signal. This is showing 19.8, so it may not be precision enough to do any calibration. But also I can drop this off of a building and I'm not going to cry when I'm going down the ladder to get it. I'll just go get another meter. But let's take it to the 20 milliamp scale, just so you can see. All right, well, and actually it's showing 19.81, so it's okay. But we got that 100th decimal of precision. Also, this has a backlight. Oh, look at there. Now you can see it so much better. The thing I don't like about this meter, and they did it for battery life, is the backlight doesn't stay on. You can see it's starting to fade now. So it's more of a hit it, look at it, and let it fade out. But if we bring this on up to 28.3, now it's going to show a 1, which means that it's overloaded. You're out of the range of it. And so you're going to have to go down to that 200 milliamp range. Also, it does measure microamps, so it has a wide range from 200 microamps up to 200 milliamp. But now let's say you need to measure something that is greater than 20 milliamp. Well, for this type of meter, it does have a spot that can measure up to 10 amps. Now, a few things about this is, one, especially on this one, it's unfused, and it says it right there, unfused. And that means if you take it above 10 amps, you will burn this meter up. But also, before we even do that, let's see what it looks like on our analog simulator, just so we can see. So actually, before we do this, we'll just turn this off. And now we're going to switch to the 10 amp, and we're going to move our post to that 10 amp spot. And now we'll turn our meter back on and go down to current source. And we bring it up, it's not registering anything. In fact, to get it high enough, it probably will register, yeah, it'll register 0.01. And yeah, it's not going to register any more than that. And that's because our scaling is way out of range for what we're trying to measure. This is milliamps, and this is amps. So to show an example of measuring amps, I'm going to stick a 100 ohm resistor into our 24 volt terminal block. When we measure between it and our 0 volt, we're going to get 0.24 amp. And in a later video, we'll go through how we end up getting 0.24 amps. But there's just an example of measuring amps with your meter. Now, as I said before we started in the amp area, is be very careful when measuring amps, because this is how you easily can break your meter. And I won't even say break your meter, you will blow the fuse in your meter. And the trick with a meter that has a blown fuse in it is everything works on it perfectly except amps. So right here, well, one, this one is unfused, this meter, as far as the 10 amp. So if you go above 10 amp, you will burn this meter up. But typically, especially on the smaller milliamp scale, there will be a fuse in there. And that fuse is only for the milliamps. So if you blow your fuse, you can still measure ohms, you can still measure voltage, everything will still work great. But like I've shown in a lot of other videos, if you put it on the milliamps and then you reach over here and you accidentally check across the plus 24 and the 0 volt, you'll immediately blow the fuse in the meter. I have this issue more, and I'm not trying to pick on you guys with expensive meters just because I'm holding a $25 meter, but you know, I'll have somebody call and be like, hey, your analog simulator doesn't work. I've got it hooked to my fluke meter and it's showing 0 milliamps. And immediately I'm like, hey, check the fuse in your meter. And they're like, you know, I paid such and such for this meter. There's not anything wrong with it. And I'm like, okay, let me send you a $25 meter. And if it works, then just send me $25. And they always end up sending me $25 because nobody can believe how simple it is to blow a fuse in a meter. And it still worked great. So here's a small rant about blowing fuses in meters. If you're more curious about that, I'll put some links in the description to some other videos I've done where I've blown fuses and meters on purpose just to show you how it happens. But there's a nice primer on how to use your meter. One thing we didn't actually touch on is a non-contact voltage sensor. This is not a substitute for a meter. Also, a meter is not a substitute for a non-contact voltage sensor. As I said in a troubleshooting video recently about AC motors, this thing can save your life. So if we touch an AC power source, let's flip this back around. If I touch this wire right here, then without even piercing the insulation, I can know that there's power there. So that's very useful, but it's not the same as measuring and seeing what voltage you have. Also, this does not work on DC, it only works on AC. And we're gonna do a fun video coming up where we actually make a homemade version of this to show how they actually work. So I hope this video has been helpful. If it has, please hit that like button. Till next time. Hey, this is Tim.
And this is Amber of TW Controls. We run the automation store. Hey, thanks for finding our channel.
Here's a playlist with some similar videos.
And YouTube thinks you'll like this video.
Please like our video and subscribe to our channel.
And if our videos have helped you make some money and you're not using our products, please consider supporting us on Patreon.
Till next time.
See ya!